We've been so focused on the headline-grabbing feats of AI, the models solving 50-year-old math problems or generating perfect code, but beneath the surface, a far more profound transformation is underway. It's not just about what AI can do, but how it's being built, distributed, and integrated into the very fabric of our digital and physical infrastructure. From tiny on-device models to vast, persistent simulations, the architecture of AI is quietly shifting, becoming more pervasive, more autonomous, and frankly, more invisible. This isn't just an evolution, it's a silent revolution, fundamentally altering how we interact with technology and what we expect from it. The real story isn't the AI you see, but the AI that's becoming the scaffolding of our future. The most significant shift, as we're observing, isn't necessarily in model size, but rather in how these models are being deployed. We're witnessing a dramatic push towards on-device and edge AI. According to reports, Google's LiteRT.js, for instance, now allows complex .t-flight models to run directly in browsers via web GPU. Similarly, PrismML announced its Bonsai 27B, offering 1-bit and ternary builds of Qwen 3.6 27B, capable of running on laptops and even phones. This move isn't just about speed, it's about ubiquity, privacy, and reduced latency. By shrinking powerful models and enabling them to operate locally, AI becomes less reliant on distant cloud servers, fostering a more responsive and resilient intelligence that's always present, yet rarely seen. This decentralization fundamentally changes the economic and architectural landscape of AI, and we expect to see significant ripple effects across the entire cloud computing sector as this trend gains momentum. The agentic paradigm, according to recent industry discourse and observed developments, appears to be more than just a buzzword. It's emerging as a critical operational blueprint for future AI systems. We're seeing this exemplified by announcements like Mistral AI's Robostral Navigate, an 8B model reportedly designed to guide robots using just a single RGB camera. Industry reports also highlight intense competition in agentic coding benchmarks, with Anthropic's Claude Sonnet 5 said to be narrowing the gap to Opus 4.8 and Mistral Vibe for code competing fiercely. These agents, as described by their developers, aren't just processing information. They're designed to act on it, make decisions, and execute tasks autonomously. The focus from our perspective has clearly shifted from single prompt interactions to complex multi-step workflows. This effectively transforms AI from a mere query engine into what developers hope will be a proactive collaborator or even an independent operative capable of navigating complex real-world environments. What we're watching for next is how these claimed capabilities translate into robust, real-world deployments beyond benchmark results. According to reports circulating within the AI research community, the next evolution of AI agents centers on self-improvement through continuous learning. Skyfall AI's Morpheus, for instance, is presented as a persistent enterprise simulation benchmark that reportedly makes continual reinforcement learning essential in non-stationary environments. Stanford's TRACE project takes this concept further, with researchers turning recurrent agent failures into synthetic reinforcement learning environments, aiming to diagnose and rectify capability gaps. This approach, often dubbed loop engineering and highlighted in guides on auto research and bi-level auto research, suggests AI systems are moving beyond static programming. They are being designed to learn, adapt, and refine their own capabilities through ongoing experience, effectively becoming autonomous machine learning researchers. What we're observing here is a foundational shift, pushing towards systems that can evolve beyond their initial design parameters, rather than merely executing pre-programmed tasks. The increasing sophistication of AI naturally drives advancements in its supporting infrastructure. According to reports covering developments like Amazon Bedrock Agent Core Gateway, we're seeing a clear trend towards multi-tenant agents. This approach facilitates fine-grained access control and secure integration across diverse systems. In parallel, discussions around human-centered AI and decentralized alignment, as explored by Mira Murati's Thinking Machines Lab, highlight a future where model ownership and customizable weights are paramount. This isn't merely a technological shift, it's fundamentally about control. What we're observing here suggests a future where AI isn't necessarily monopolized by a few giants, but rather distributed, adaptable, and potentially more aligned with individual and enterprise needs, moving beyond a single monolithic AI entity. The bigger picture here is a strategic move to distribute power, which could lead to more tailored, albeit potentially more complex, AI deployments. According to reports we're tracking, the underlying infrastructure supporting AI is undergoing a radical transformation, shifting towards specialized hardware and optimized software solutions. NVIDIA, for instance, has been exploring tile-based GPU programming through initiatives like Qtile and Triton kernels, which suggests a clear push towards hardware engineered specifically for AI workloads. On the software front, we're seeing frameworks like Bloom emerge, designed to make documentation inherently AI-ready, while Open Core Dev's Domain SDK aims to streamline multi-platform domain management. This movement isn't merely about faster processors. It reflects a broader industry effort to construct an entire ecosystem where every component, from the foundational hardware to the deployment tools, is optimized for an agentic, on-device, and continually learning AI paradigm. What we're observing is the foundational bedrock being laid for the next generation of AI capabilities, with a clear emphasis on integration and purpose-built design rather than general-purpose computing. The increasing pervasiveness of AI, from neuroimaging foundation models like NeuroVFM to generative AI scaling UX testing with Amazon Nova Act, brings both incredible utility and significant ethical challenges. According to reports, the ability of models like GPT 5.6 Sol Ultra to generate proofs for 50-year-old math problems highlights AI's intellectual prowess. Yet, the rise of AI agent crawlers requiring explicit permissions and the concerning use of platforms like YouTube and X as gateways to nudify apps underscores the urgent need for robust ethical frameworks and regulatory oversight. As AI becomes more deeply embedded and autonomous, managing its impact and ensuring responsible deployment will be the defining challenge of this new era. From our perspective at ToolScout, the critical point here isn't just the technical capability, but the accelerating pace at which these ethical dilemmas are manifesting, often outpacing the public's awareness or the speed of regulatory response. We're watching to see if industry self-regulation can truly keep pace, or if a more proactive external push will be required. So, what does this all mean? We are moving from a world where AI is a tool we explicitly use to one where AI is an invisible, autonomous layer orchestrating our digital and physical realities. The future of AI isn't just about what it can do, it's about how it's woven into the very fabric of our infrastructure, learning, adapting, and operating beneath the surface. The real intelligence will be in these unseen architectures, silently shaping our interactions, our work, and our world. Subscribe to ToolScout for more original takes on the future of AI.